Hi, welcome to the introduction video for Module 4. Module 4 deals with inequalities and absolute values. And the thing we're going to talk a lot about in this module is that inequalities and absolute values have lots of numbers that make them true. So because there's more than just one number, this module we need to figure out a way to express or write all of the numbers that make it true in a more efficient way other than listing each individual one every time. So what we're going to do is we're going to spend a lot of time talking about finding a way to represent the set of numbers or a bunch of numbers that makes the inequality and absolute value true. So just a reminder that an inequality deals with these greater than or less than symbols. In this case we have a greater than symbol. And an inequality is just an expression that's greater than or less than another expression, and we have to figure out when is the expression in this case, when is the expression on the left more than or greater than the expression on the right. And just for an example, maybe you want to talk about two cell phone bills, and the cell phone bill over here on the left will represent a cell phone bill that charges you $50 plus 10 cents for every minute you go over. And you don't know how many minutes you go over, so we'll call it X. $50 plus 10 cents per minute. 10 cents times X. You got to figure out when that cell phone bill is greater than this cell phone bill that charges you $75 plus 5 cents for every minute that you go over. And we can figure that out by doing some algebra. Let me erase some stuff and we'll do some algebra here in just a second. Like we'll get all the variable terms on one side. I'll do that by subtracting 5 cents X on both sides. That leaves me with 5 cents X. Nothing happened to the 75, but the X's are gone over on the right. Nothing happened to the 50. Now all the X's are on the left, so I need to bring the 50 over with its opposite, subtraction, to the right. So 5 cents X. 0.05 X is greater than 25. And finally divide all 5 cents. And if you do that calculation, 25 divided by 0.05, it says that the X values have to be greater than 500. So what does that tell us? That tells us the answer to our question. The question was right here. Question: when is the expression on the left greater than the expression on the right? Here's the answer. When you go over 500 minutes over your limit. So if you go 501 minute, 502 minutes, 503 minutes, all of those minutes will make the expression on the left more than the expression on the right. That's a lot of numbers. That's a whole big bunch, and we're not going to write 501, 502. We're not going to write all those numbers individually. We have to find a way to express all of the numbers that make the inequality true. One of the ways you can do it is with a number line. And here we have the number line, and all of the values that made the equation true was all the values that were greater than 500. That's all these values that are greater than 500. In this case it did not include 500, so we need a parenthesis, not a bracket. If it did include 500, first of all it would look like this. The X value is greater than or equal to 500, but that's not what it said. If it was equal to, then I would have a bracket instead of the parentheses, but that's not what it said. It just said greater than. So in this case we're going to represent all of the X values on a number line, and we can use something called interval notation. In interval notation we read the number line from left to right, and from left to right I don't see anything. Here is me. These dotted lines are my eyes following. I don't see anything from left to right until I get to 500, and then I see a pair of parentheses at 500. and then it doesn't end ever. So that means it goes all the way up to positive infinity, and it never ends. And infinity is always associated with a pair of parentheses and not a bracket. So that's interval notation. That reads that the x values start at 500. Start at 500, not including 500. There's the parentheses. And they never stop. It goes all the way to infinity. That's all the values. You don't have to list them out individual. You know that that includes 501, 502, 503. I don't want to list them all out. You want to use interval notation or set builder notation. Set builder notation represents the set of numbers that make it true. Set builder notation starts with a squiggly bracket, and it states your variable. The variable we're using is x. And then you have a vertical line. The vertical line says, here's the story about x. The literal translation is x such that, in other words, here's the story such that, and then such that what? Such that the x values have to be greater than 500 in the squiggly bracket. So now we know two kinds of notation. We know interval notation and set builder notation. Both say the same thing, that there's a bunch of numbers that make this true, not just one number, and we're not going to list them all out, so we got to find different notation, like set builder notation or something else. Something else that you'll see in this module is absolute values. And absolute values just tell you the distance from zero. That's the absolute value. So in this case, you'll see that when you deal with absolute value inequalities, like the absolute value of x plus 2 is greater than 4, in this case you set up an OR statement. X plus 2 could be greater than 4 or less than negative 4. That's how you handle absolute value greater than symbols. How you handle less than symbols is a little bit different, but you'll learn it in the module. And then you have to solve each one individually. So I'll go ahead and do that. I'll subtract 2 on both sides. X has to be greater than 2. Same thing here. Or x has to be less than negative 6. So we have now two qualifications. It has to be greater than 2. Let's get our number line going here on the next slide. I'm not quite ready for interval notation or set builder. I'll come back to it. So let's see. What's our qualifications here? Forget. Has to be greater than 2. Okay, so here's 2. Has to be greater than 2. Not including 2. Okay. And has to be less than negative 6. I'll put that on the number line as well. Less than negative 6. So maybe negative 6 as out here somewhere. It has to be less than negative 6. That's all these values right here. And it does not include negative 6, so it's a parenthesis. Let's do the interval notation for this guy. The interval notation, read it from left to right, you see the values being shaded in automatically. It starts actually with negative infinity, and then it stops at negative 6 and doesn't include negative 6, so it gets parentheses. And then we get some more, so it's going to be united, union, that's why we got a U. It's going to be united with, let's keep reading, keep reading. It's going to be united with values that start at 2, and then they never end, so it goes to positive infinity. So that's the interval notation for this set. It starts at negative infinity, ends at negative 6, that's these guys, united with, union, values that start at 2 and never stop. They go all the way to positive infinity. That's That's the interval notation. Let's talk about set builder notation. The set of numbers is all of the x values such that the x values are, do you remember, less than -6, or the x values that are greater than, what was it, +2. So we got set builder notation, we got interval notation with the number line, all telling us, so we got set builder, we got interval, all telling us what makes this absolute value inequality true. Alright, so interval, set builder notation can all tell us the set of numbers, the group of numbers that make the inequality or absolute value true. Okay, good luck on your homework for Module 4.